welcome to this YouTube channel. Now, today I want to talk about creation of an NFT, and the NFT we are going to create here is the verification NFT, just but an overall one that can be used in verification of various documents. So I'm going to use here Remix ID. Remix ID is used in basically creating smart contracts, and you will be able to at least deploy them. So on the Remix ID, I will create a new file. This new file, I will call it, maybe let's say, for example, we are creating an NFT for verifying passports. We want to verify passports within a decentralized chain so that, for example, when a person goes to another country, he or she can be able to at least the verification can take place whether does not require so much of exchange between countries, but when we have the information within a decentralized chain or the passport number within a decentralized chain, we have the verification becomes very much easier. So let's say, for example, I will have a file here. I will call it passport verification. Passport verification .sol, that is the Solidity. Now inside passport verification, we are going to write the smart contract that we are going to use especially in the verification. So more so when we are starting with Solidity, we know that the first thing that we are supposed to work with is do the pragma, initialize that the file that the Solidity version that we want to use within our smart contract. So the first thing we are going to do here is do pragma Solidity, and we are initializing this Solidity to use version 0.8013 and above. The next thing is importing certain important libraries that we can use, especially in our smart contract in this NFT. And the most important library that we can import here is two libraries: the Open Zeppelin library for the ERC21. So I have imported them. We have the ERC21 library and the counters library. These are what we are going to use in creating this our NFT. So let's say in initialization of NFT we have here, we are first of all supposed to initialize it to have the license identifier. As per now, we are going to create the license identifier to be under the MIT license, which means that this is an open source contract. So the next thing now, we are going to start the creation of the contract. So we are going to create a contract. This contract, we are going to call it passport verification NFT, and the ERC21. So inside here is where now we want to generate the code that we are going to use for this password verification NFT. So so the next thing we are going to do is using the counters, because the counter is supposed to enable us to be able to at least generate new identity each and every time we are creating, for example, an identity within the passport verification NFT. So suppose you are creating an identity for one person and then you want to add more, then the counters enables you to do so. So we are going to use using counters for dot counter. That is the library that we have imported. So for us to use it more nicely, we are going to take counter counters dot counter, and this one is going to be private, so that we can be able to at least name the token IDs that are generated to be private within the net. The next thing we are going to have is the struct data, where in the struct data we are going to have the details, struct identity for the different people within that we are working with within our NFT. So we are going to have a struct, for example, with the first thing that we normally have, for example, in creation of data that is used to describe a person, we are going to have an ID, and this ID is going to be uint 256. Uint 256, that is ID. The next one is the address that is used to identify the owner. The next thing is the name. So name do normally take the data type of string, the name of the person. The next thing is if we, for example, decide to pick email of the person. The next data type is the ID type. Let's say, for example, the one we are working with here, we are going to name it as passport. So we are going to take like string ID type. Then the next thing is going to be the ID number, which is like an identifier. So that one is going to be a string ID number. The other thing is about the verification status, especially when we are doing verification, we want to see whether it is a success or it has failed. So that one we are going to use the Boolean way of verification. So in doing the Boolean way of verification, we are going to pick create a Boolean expression for verification, verified. So let's say that that is the struct data that we have. And now we are going to map this struct data to identities, so that at least we can be able to store all the data to the created identities. So the next thing here is about mapping. The uint 256 mapped to identity, the identity that we have created in the struct, and this is going to be like the public that is mapped to identities, public mapped to identities, because we can create several of them. So the next thing here, we want to give a name, create a constructor, and this constructor is going to be able to at least, whenever we deploy this NFT, we can be able to at least see it and be able to get it on the chain. That is especially when I'm deploying on the Ethereum chain. So I'm going to create a constructor. This constructor is going to pick ERC 721, and the verification here is the name. The name for this NFT is passport verification NFT. The short code that we are going to use, especially like the symbol, let's say we are going to use capital P PV NFT. So that is the passport verification NFT. Then that is the work at the constructor. Now from here, now we are going to create a function for that enables us to be able to at least create an identity within create an identity for each and every person that we are working with or within our NFT. If you are creating a passport, you have always to create it for a person. So let's say, for example, function. We are going to have a function create identity. So when we are creating identity, we are going to have some of the details, especially that we had mapped. So we are going to have string memory mapped into name. We are creating a memory space for name. Again, we are creating a string memory for the email of the owner. We are going to create enter the other detail for the owner, that is memory ID type. Then the next one we are going to do is your pick ID number. So we have string memory ID number, then all these are going to be public details that returns a unit. Now inside our function, now what we are going to do is to have the token IDs that we had initialized up here. That is going to be like token IDs incremented whenever we create a new identity. So token IDs dot increment. That is going to be incremented whenever we create IDs. You can use this NFT to create IDs for several people within a network. So from there, now we are going to generate a new ID, and for us to generate a new ID, this new ID is going to be a uint. That is a uint new identity ID is equals to the current token IDs, not current. So this is supposed to be a uint, and let us map it to uint 256. Yeah. So that is creation of identity. So the next thing is we are going to do is creation of creating a new identity struct with a passed in parameter and the default verification status of false. So that is what we are going to create as per now. So the next line, what we do is identity memory new identity is going to be equals to identity. It's going to be equals to identity, which is the new identity ID, new identity ID. We get a message if the ID is there, dot sender, which is going to be mapped to email. Start with the name, email, the ID type, the ID number, and here we mark it as false. Now, still inside our function, we are going to be able to map creating the new identity is supposed to be mapped to the struct data. So what we are going to do here that follows is take the identities that we had created here as public identities, which is going to be an array. It's going to be equals to new identity ID is equals to new identity. The other thing is inside that's our function, we are going to be able to at least mint a new NFT token and assign it to the owner. So from here we can, this is just an overall NFT, an overview of how NFTs work within a decentralized chain. So this our function is going to have a message.sender to the new identity ID. Good. Now what we are returning here, because we had said that whatever we are returning here is a uint 256, which is a value. We are going to return the new identity that has been created. Return new identity ID. Good. So this is what we have created as the first function that is enabling us to be able to create an identity. So once we have created an identity, let's look at another function that can help us, especially in verification of the identity. So we are going to take function verify verify identity, which is going to take the parameters of uint256 and identity ID. And this is going to be public, because whenever we are doing a verification, especially with the passports, it is verifications are being done in the public. So this will require you to be able to do the verification, especially verify that the caller is the owner of this passport. So what we will do here is have nsg.sender equals to identities, because we must verify this through the chain. So identities that is within the array of the identity. So we are going to take identity ID, and then we map it to owner. So if it is this is supposed to give us a message, and this message that it is supposed to return, let's say for example only the owner can verify the identity. The other thing is about setting the verification status of the identity to be true if suppose it is existing within. So we're going to take identities mapped to the identity ID dot verified equals to true. So let's say we have written a smaller contract here. This is a smaller NFT contract that we have written to enable us be able to at least process different NFTs. So this is ERC. Within verification, I'm just trying to look at the errors that I have here so that I can correct them. Now, this is the smaller contract that now we have here for verification of identities. Now, if you look at the menu bar here, the graphical representation on the remix ID, we have here telling us that the autocompile, once it is blinking green this way, it means that the contract is compiled successfully. So on the deployment of the contract, I want to deploy this contract on Sepolia testnet so that I can be able to see it. Whenever you want to deploy such kind of a contract on the Sepolia testnet, so ensure that you have some Sepolia, so that at least to enable you be able to connect to this testnet. For now, I have 0.9846. To get the Sepolia, you are going to get the Sepolia through the Sepolia faucets. For example, sepoliafaucets.com. I'll place the link on the description. The link will be on the description. so that here you are going to enter the wallet ID, the wallet ID that is here. So you're going to pick this one and place it here, and click and ensure that at this time you have an Alchemy account. Then when you do a send, you will be able to be given Sepolia testnet. This shows that I've been given some Sepolia testnet. So when I go even to the Etherscan, which is Sepolia Etherscan, enable us to see the transactions. You can see here when it is being generated within the chain, it is showing us the transaction is still pending, so that it can be verified and be added to the chain. That is the Ethereum network chain. So let's give it time. Good. Now you can see here the status of this transaction has changed to success, and therefore when I go to the Sepolia, to the MetaMask, which is acting as a third party for holding our wallet, you can now see the 0.5 faucets have been added to my Sepolia account, and now I have 1.4846. So this is going to act like the testnet for deploying our contract. So on our environment here, I'm going to inject MetaMask. Whenever I inject MetaMask, it's going to pick the address automatically, and then here I'm going to deploy our contract. So when I click on deploy, the verification is being done on the MetaMasks, and I'll be requested to do the confirmation through the testnet, and here I will confirm. The same thing is going on the Etherscan. So good. So once it has been verified, I can refresh this, and you can see that the transaction has become a success. And what now happens is that when you do the MetaMask and it has been deployed, you will see the passport verification here. It has been deployed. From here, I can be able to at least create identities. Can be able to at least create an identity. Let's say, for example, my name is Boston. I do boston@gmail.com. ID type is passport, and I do an ID number of maybe 1, 2, 3, 4, 5, 7, 8, 9. Then I transact to create that ID. So when I confirm, the Etherscan here is always showing me the IDs and the token ID of the verification of the ID that I have created. So I will take this, and because this is an NFT for passport, I will import the ID, which is 1. And because here it shows that we have the ID verification as 1, then I will add. Then you can see our passport verification NFT has been added in the Sepolia testnet. So from here, I can be able to at least look at identities here. I look at one, then call it. I can be able to see the different details that I entered. The verification of identity, I can do 1 if I want to verify, because our identity is mapped as the first one within our NFT. So here I can do the verification if it is existing within the chain, and we are waiting for it here to be validated. Good. So you can see from Etherscan, I can be able to see it is still loading to verify our identity. So this is the process that happens, especially when an identity is being verified within the chain, so that you can be able to see that this is an identity that is existing. So when it is a success this way, it means that our identity that we were looking for is existing within the chain. So this is just an approval, which we can call. An approval helps you in getting the different addresses. Here we can approve the address of the identity that we had created. So we have the address there. That address is what we paste here, and then we verify that identity. We approve it that it is supposed to be existing within our chain. So once it has been approved, it is still going through the process of approval. It has been approved. Now when I go here and get if the contract has been approved, you can see now the 00 changes. So it means that the address that we entered for the owner here, or the identity that we had created, has been approved within this contract. This contract, we have its name as passport verification. It has a symbol of PNV, the URI, which is the token ID. I can still enter that. Same here, which is supposed to be like something like a string. So this one is an NFT that you can use in verifying the different details. Right now we have tested it on the Sepolia testnet using Remix ID. The next one, next video that will follow will be the deployment of this contract on the Sepolia testnet using Trafo, and the other API configurations like using Alchemy. Thank you.